two subintervals of equal width, and then approximated by using the trapezoidal rule with two equal subintervals. The difference between the two approximations is.
So we have two subintervals. Let's write x and y. We know we have to start at 0 and we have to end at 2. What number has to be in the middle then? 1. And if you realize our two subinterval is going to be right there. So if I plug in the 0, we're going to get e to the power of 0. What is e to the power of 0?
1.
1. And then for the next one, we could write out just e. Because e to the power of 1 all squared is still 1. And then we have e to the power of 4. So on our, it's asking us to compare, right? Left versus who? Trapezoidal? So for the left, let's write out on the bottom. For the left versus a trapezoid. So just looking at this, my left one is going to be 1 times 1. And the times 1 comes from the difference between the x's. And then the next left is going to be e or e to the power of 4. Who is on the left between these two? E. Times 1. That's going to give us, since calculator's allowed, when I type this in, I know e is about 2.71, but let's actually type in the e. Uh-oh, there it is. E plus the 1. And that's about, since the norm is 3 decimal places, let's make it 3.71 what? 1/8. For my trapezoid, we add the 2 divided by 2 times the difference of the x's. So for this one, we have 1 plus the e divided by 2 times 1. For my second one, we have e plus e to the power of 4 divided by 2 times 1. And again, if you were to type this in, just like that, it's going to give you some number. And someone give me that some number. Are you counting desk? I got 34. And a clock. And a board. All right, about how many?
30.517.
Correct. And notice on this one, it's asking us the difference. So if you got excited to see 30.51 on B and then choose that answer, that's going to be a problem. So when I subtract between those two, we should get D, 26.80. Good job. Okay, our next one is number 7. Go to number 7. All right, on number 7, it looks like we're looking at U substitution. Well, let me get to it. Is 7 calc or non-calc? 9, all right. That's 11, yeah. It'd be nice to move this over. All right. Which one are we going to let U equal? X squared plus 2x. You should always be equal to one more power, okay? Whichever one has a higher power. So on this one, all that right there. And wish me luck in spacing. So let's write on here, we have u is equal to x squared plus 2x. And that's going to give me du is 2x plus 2 dx. Are we okay with that? All right, the only issue is, my goal is to make x plus 1 dx. Is there a way to do that by dividing by something? Good. So we have 1/2 du is equal to x plus 1 dx. So now all that is plugged in by half of du. What constant am I going to kick out? The 1/2. So I'm going to kick out the 1/2. Then we have the integral. And we have 1 over u du. I do want to change our value as well. If the initial value was 2 and the 1, and I plug it into this equation, what is my new bound for the upper bound? Plug in 2 and 2, we get 8. Plug in the 1 and we get 3. So my lower bound is 3 to 8. So we know integral of 1 over u is what? Uh-oh.
Oh,
Natural log of u, and our bounds are 3 to 8. Do I need plus c on this one?
no.
Why is that? No plus c because we have our bounds. Because it'll be added c, subtracted c. It's going to cancel each other out. So now let's go ahead and plug these in. So when I do, I get 1/2 of natural log of 8 minus 1/2 of natural log of 3. And is the answer pretty much there on this one?
Yes.
What else can be represented by 1/2?
Over 2.
All over 2. So we're looking at B. That's a proud moment. It fit. Almost. All right. Let's go to number 11.
Miss Brooklyn,
Uh-huh.
how did you get the sheet note whenever you substitute the?
How did I get the what?
Never mind, now you're explaining it.
We're good? Okay. All right, on number 11. Luke, let's read.
Number 11.
Uh-huh.
How do you read that?
Very carefully.
Okay, 'cause the
The integral.
Integral of
Uh-huh.
x squared.
integration.
You can't really read the copy. It's over e to the power of x squared.
X cubed.
Yeah, I can. X cubed dx.
Okay. I want to rewrite this to bring the e to the whatever as a non-fraction. So let's write the integral of x squared. And when I bring the fraction on the bottom to the top, what sign becomes or comes along with the power? We get negative, and it was actually cubed. And I do agree it is kind of hard to read. Now, if y'all remember when we were deriving with the e, what was supposed to be set as our u equal to? The exponent. Very good. So we have u is equal to negative x cubed. And when I derive, I get du is negative 3 x squared dx. And when I compare, I see x squared, I see dx. What do I need to move over? The negative 1/3. So when I plug it in, I'm going to get, first let's kick out the negative 1/3, e to the u du. And the derivative of e to the whatever is e to the whatever. So in this case, we have 1/3 e to that whatever. And then on this one, there's no bound, so we have to put what? Plus c. And let's look at our, ooh, I forgot my negative. Okay, what answer choice will give me that? 1/3 means 3 is all on the bottom. Oh, did I forget to plug back in the u? What a sad day. Did anyone catch that? That's okay. So our u was negative x cubed plus c. So now I know I need to bring this whole thing to the bottom, right? All that to the bottom. So we get negative 1/3. Oh, let's bring it all right here. Ooh, awkward. So now we see answer choice must be C. That's a power of 3 on top of the x.
With the x, yeah, the x should be positive.
It should be positive, right? Since I brought it down. Was that Hannah?
Now you can have it.
Okay.